Hi, good morning. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. And today, in our AIML lecture series, we are at the final unit, that is deep learning. In this unit, we are going to discuss the first topic, that is convolutional networks. So, come, let's get into the topic. So, actually, what is conventional neural network? So, the conventional neural network, it is simply represented as CNN. It's a type of deep learning neural network architecture commonly used in the computer vision. So the computer vision is a field of artificial intelligence that enables a computer to understand and interpret the image or visual data. So when it comes to machine learning, artificial neural network perform really well. Neural network are used in the various data sets like images, audio, and text, and different type of neural networks are used for different purposes. So based upon the applications we can use for any neural network. So this is the CNN architecture. Here we have an input layer. Input layer we have, for example, if you take image. So next layer is convolutional layer. Then next one is a maximum pooling layer. Then dense layer. Then output layer. So this is the simple architecture of CNN. So how convolutional layer work? That means convolutional neural networks are neural networks that share their parameters. Imagine you have an image. It can be represented as a cuboid having its length, width. Width is a dimension of the image, and height. It's the channel, as the image generally have red, green, and blue channels. So the below is the image which is considered as a input, right? And now imagine taking a small patch of this image and running a small neural network called a filter or kernel on it with say k output and representing them vertically. Now slide that neural network across the whole image. As a result, we will get another image with a different width, height, and depth. Instead of just RGB channel, now we have more channel but lesser width and height. This operation is called as convolution. If the patch size is the same as that of the image, it will be regular neural network. Because of the small patch, we have this kind of a weights. So what we have seen in the previous slide that is shown here. So here the width and height, then the patch and RGB and Y and X axis and K is represented in this image. So let's see the classroom activity. So we have some mathematical puzzle. The given number is 1, 3, 5, 7 and 9, 11, 13, 15. From this data, right, we have to find out the empty circles, what actually the appropriate number will come. So you just discuss with your team members and find out the answer. And so the next one is a mathematical overview of convolution. So convolution layer consists of a set of learnable filters, that is our kernels having small width and height and the same width as that of the input volume. 3 if the input layer is image input. For example, if we have to run convolution on a image with dimensions 34 into 34 into 3, the possible size of filters can be AX3, where A can be anything like 3, 5 or 7 but smaller as compared to the dimension image. That is a image dimension. It is a very important one. So during the forward pass, we slide each filter across the whole input volume set up by the where the each step is called stride, which have a value of 2, 3, or even 4 for higher dimension images, and compute the dot product between the kernel weights and patch from the input value. As we slide our filters, we will get 2D output for each filter, and we will stack them together. As a result, we will get the output volume having a depth equal to the number of filters. The network will learn from all the filters. So let's see the assessment. The first question is, what is CNN? That's a convolutional neural network. And what are the advantages of CNN? The third one is applications of CNN, and list the drawbacks of CNN. And the next final question is, what are the steps involved in the mathematical convolutions? So the next session, we will see the next topic in the deep learning unit. So thank you.